Alright, my beautiful grade 10s, welcome back to another video. Alright, the Lord has given us a beautiful new day, and let's jump into some mathematics. Okay, so we're going to be doing some nuts and bolts today. Okay, so what I mean by that is there's certain things about graphs and the different functions that we have. So we've got 4 different functions. We've got our straight line, we've got our parabola, we've got our hyperbola, and we've got our exponential. Okay, and in those 4 graphs, we've got certain things that we need to know and understand about those 4 graphs, okay? And certain things that we need to wrap our heads around, okay? So, jumping straight into it, let's look at this. Okay, so we've got our straight line, okay? So straight line, how do I know it's a straight line? Because there's no x squared, it's not 1 over x, and it's not, x is not a power, it's not an exponent, okay? So it's just x, negative x, minus 1, which is just a normal straight line graph, and that's what it looks like. I've got my points and I've got the name of my graph there. Okay? Now, if I look at the domain, okay, if I'm talking about domain, okay, domain is just all the x values, okay, that satisfy my graph. Okay? So all that means is that if I pick any x value, let's say I pick negative 4, and I draw a line straight up to my graph, okay, is that line touching the graph? Yes. Okay, and a better way to illustrate this is if I draw a ruler. If I take a ruler, okay, let me draw a ruler here. Let's take that, draw a ruler. Alright, if I take a ruler, okay, and I put my ruler, okay, I put my ruler on my x-axis, okay, vertically up, okay, my ruler is vertically up, and I go to point negative 4, alright. Is my ruler touching the graph there? Yes. Is my ruler touching the graph there? Is the green touching the pink over here? Yes. Is the negative 2, okay, is it touching? Yes. Are they crossing? Yes, they're still crossing. Okay, if I go there, is the green still crossing the purple? Yes. If I go there, yes, it's still crossing. Whoopsie. Okay, if I go to 2, still crossing there. Alright, okay, if I go to 3, it's still crossing. If I go to 4, it's still crossing. Alright, and just remember, so I keep moving the actual graph. Alright, and just remember that this graph will continue going that way and continuing going down like that. So it always goes up for infinity, it keeps going up, and will keep going down for infinity. Okay, so it doesn't matter how far I move this ruler. Okay, that green ruler is always going to touch this pink graph over here, or purple, whatever, if you're an art student, I don't know. Okay, whatever color this is. Okay, it's always going to touch, right? Okay, so for every x value, okay, let me ask you the question. For every x value, do I have this line touching my graph? Right? So we already went through it, negative 4, negative 3, still touching. Right? So will there be any x value where this ruler will never touch my graph? No, for every x value, this ruler is touching this graph. Alright, so every single x value that I have on my x-axis, I'm going to touch a graph if I put a ruler on it. Okay, vertically up on it. Okay, so we're going to have x is an element of real numbers. Okay, so that just means that every single x value that I could possibly think of, if I put a ruler vertically up on that x value, there's my x value, and I put a ruler vertical on that line, on that point, right, eventually that ruler is going to cross with my graph there. Okay, nice and simple. Alright, now it's the same thing with the range. Now the range is all my y values. Okay, so I'm going to take this ruler, I'm going to now flip it on the side, okay, because now I'm going to do the y values. Okay, so if I go to my y value here, and I go to 1, okay, there's a y value of 1, and I put my ruler there. Is my ruler touching the graph? Yes. Is my ruler touching the graph there? Yes. Is it touching there? Yes. There? Yes. Is it touching there? Yes. There? Yes. Yes. Alright, so on every single y value that I could possibly think of, if I put this ruler here, and the ruler is infinitely large, okay, it doesn't matter. Okay, if my ruler is infinitely large, my ruler will always touch this graph. Doesn't matter what y value I put it on. Eventually, if I follow along the ruler, it's going to touch the graph. Okay, so it's the same there with the y values for my straight line graph. Okay, so my range, okay, I'm going to have every single y value that I can possibly think of, okay, which is y is an element of real numbers. Okay, and there we go, there's the range. Okay, so that's domain and range. Okay, so domain is all my x values that if I pick any x value, okay, it's going to touch the graph. Okay, it's what satisfies my graph. Okay, and the same with the range, the y. Okay, it's all the y values that satisfy my graph. Okay. Alright. Now, the values of x when f of x is greater than 0. So let's just understand what that means quickly. Okay. So, if I'm talking about f of x, okay, what is a fancy... so what does this mean actually? It's just a fancy way of saying what? It's just a fancy way of saying y. So what they're asking me is they're asking me where are the y values for this graph greater than 0. If I'm talking about greater than 0, numerically, what are you thinking of? You're thinking of positive values, okay? So, where are my y values on my Cartesian plane positive? Above the x-axis or below the x-axis? Above the x-axis, okay? So basically what they're asking here is where is my graph above my x-axis? Okay, so in order to determine that, we always look for my x-intercept first. Okay, so let's go determine our x-intercept first. So what is my x-intercept of this straight line? Where does that graph cut the x-axis? Over there. Okay, there it cuts there. Okay, now I'm going to get a highlighter, okay, to make this clear to you guys, because some of you guys just can't see this. I don't know how. Alright, but if I now put my highlighter on this dot, okay, and I go, remember I'm looking at the x values, right? Find the values of x when the graph is above. Okay, so I'm going x values. So am I going up and down, or am I going left and right? X values are left and right. Okay, so if I go to the left of this dot and I go this way, okay, where's my graph? Okay, look here. Where's my graph in this area over here? My graph is above the x-axis. Okay, so if I go to the left of this dot, my graph is above. There it is. Let me just make this a bit thicker. Okay, so there it is. Alright, so that's to the left. That's all these x values here. Can you see? Let me put this in red. All these x values here to the left. Sorry, put it in red. Right, all these x values here. Right, all of these x values here to the left of -1. Okay, can you see that all these x values, my graph is going to be above the x-axis. Can you see that? It's above the x-axis. There's my graph. It's above. Right? But as soon as I go this way and I change direction and I look at all of these x values to the right, okay, to the right of this blue dot, okay, this blue dot over here. Okay, where's my graph now for all of these x values? My graph is, if you look at this area over here, it's underneath. Okay, go to my highlighter. There it is. My graph is underneath my x-axis. Okay, so for all of these x values here, can you see that my graph is underneath my x-axis? It's below the x-axis. Okay, so if they're saying find the values of x when f of x, or the y values, are greater than 0, that's when the graph is above the x-axis. Okay, and we found the not the asymptote, sorry, the x-intercept. X-intercept is there. Alright, and we said to the left or to the right of this dot. Okay, my graph is where? Okay, so to the left, my graph is above. Okay, and to the right it's below. Okay, so now they're asking me, where is it above? Greater than 0. That's to the left, over here, to the left of this blue dot, to the left here, my graph is above. Okay, so to the left of x means that all the x values are bigger or smaller than -1. X is smaller than -1. All these values, -4, -3, -2, are all smaller than -1, and these values continue that way, and that graph continues. So to negative infinity, it's going to continue. This is going to keep going up, keep going down. Okay. Alright. Now if they ask f of x is smaller than 0, that's going to be, if it's smaller than 0, it's below the x-axis. Okay. So I find my x-intercept. There it is. Go to my blue dot. Okay. And where's the graph below the x-axis? Is it to the right of the dot or to the left of the dot? To the right. Okay. So to the right, all of these x values, okay, my graph is going to be below. Okay, for all of these x values here, for infinity and beyond. Okay, to infinity and beyond. Toy Story. Alright? So x, okay, if it's to the right, all of these x values are bigger or smaller than -1. Greater than -1. Okay, I hope that's clear now. Right, I know you guys really struggle with this, but I hope that's getting clearer. Okay, so moving on. Right, now I'm looking at a parabola. Okay, how do I know it's a parabola? Because of my x squared there. Okay, because of my x squared. Right, now I know it's a parabola. And I know it's a positive parabola because that's a positive 1 there in front. And there's my, not my asymptote, sorry, my turning point. Okay. Now, if I look at this over here. Okay, so there's my points. So that's -1. That's 1 over there. And that's -1 for y. Okay. My domain. Okay, if I talk about domain, what am I asking you? All my x values. Alright, so let me take a ruler again. Okay, let me draw a ruler. Straight down. Here we go. Alright. And so over here, just remember that this graph is going to continue forever and infinity. Okay? Up that way and forever infinity up that way. So it's going to keep going up. Okay, and to the side. So it's going to eventually it's going to get to this area and it's going to keep going up. Okay, but there's no space on my laptop here. Okay, to keep going up. Okay, and it's going to keep going up forever and ever and ever and ever and ever. Okay, so if I take this ruler and I start over here. Okay, so firstly, these values are going to keep going up. Okay, so all of these x values here are eventually going to touch a graph if I put my ruler on here. Okay, if you could see it, if I could extend my laptop, you'd be able to see it. Okay, so let me go to the where I can see. There it is. Okay, so all these x values. Okay, is my ruler touching the graph? Is the green touching the pink or the purple or whatever you want to call this color? Yes, it's touching, it's touching, it's touching, it's touching. Keeps touching, it's still touching. Still touching, still touching. Okay, and it's always going to touch past this point. It's going to keep going up. Okay, I'm going to keep touching that graph. Keep touching till infinity. Alright, if I go the other way, touching, 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 touching. Alright, and all the way this way, between negative infinity, okay, because it's going to keep going up, keep going to the side here. Okay, so this ruler will always touch this graph for all these x values. Okay, so basically, what am I asking here? The domain is what are the x values that satisfy my graph? Is it all of them? Are some missing? It's all of them, all my x values that I can ever think of, from negative infinity to positive infinity. I'm going to eventually touch my parabola if I put my ruler on that x value, whatever I choose. Okay, I'm going to touch my parabola. Alright, so x is an element of real numbers. Okay, so that's all my x values satisfy this graph. Okay, now the range. Okay, the range, so I'm going to flip my ruler. There it is. Okay, flip it. Okay, I'm going to put it on my y-axis. Okay, so remember, I'm coming from positive infinity here, all the way up here. Okay, and I'm starting to come down. Remember, my graph is still here. My graph is still here, because remember, this is going to come all the way up, all the way up. Okay, so I'm still touching graph, I'm still touching graph. Graph is still touching, still touching. The green is still touching the pink there. Still touching, still touching, still touching, still touching. Alright, now, is my ruler touching the parabola here? Is it touching? Can you see it's not touching the parabola? Alright, so at what point did that happen? Can you see it? I'm still touching the parabola here. I'm touching the parabola. Still touching, still touching, still touching. I'm still touching. I'm at the turning point. As soon as I go below the turning point, oh no, there's no graph anymore. I'm not touching the graph with my ruler anymore. As soon as I go below that point, my turning point, as soon as I go over or below, sorry, as soon as I go below that -1 and I go to -2, can you see that my ruler is not touching the parabola? My parabola is completely above this ruler over here. Can you guys see that? Alright, so what are my y values that satisfy this graph? All the y values greater than or equal to -1. Okay, so that's the turning point. The turning point is over there. Okay, if I'm touching -1, am I touching the graph? Yes, because my turning point's there. And if I go above -1, I'm touching the graph, touching the graph. As soon as I go below -1, there's no graph, nothing. Right, do you guys see that? Okay, so it's all the values greater than -1 there. Okay, my axis of symmetry. Okay, what is an axis of symmetry quickly? Let's revise. Axis of symmetry is a line drawn straight through my graph, okay, and it cuts my graph evenly on both sides, basically, right? So if I could flip my graph over on either side of this line, okay, my graph is going to look exactly the same, okay? They mirror each other. So if you put your hand on this green line, okay, can you see that on either side of your hand, right, you've got something that looks exactly the same, just mirrored on itself. Okay. Alright. So what is the equation of this line where this happens? Okay, so on this line, this is symmetrical. Okay. So what is the equation of this line over here, this green line? X is equal to 0. Okay. X is equal to 0. Alright, now let's revise this again. Alright, so to take my ruler away. Alright, f of x, find the values of x where f of x is greater than 0. Okay, so when I'm saying f of x is greater than 0, what am I saying? What am I looking for? Where my graph is above the x-axis. Okay, so firstly, I need to go and find my x-intercepts. Okay, so let me go find my x-intercepts. Okay, there's one. Okay, my graph cuts the x-axis there, and my graph cuts the x-axis over there. Okay, can you see that? Alright, now let me get my colors. Okay, before I do it, I want you to go and highlight all the parts of this parabola that are above the x-axis. All of them. I want you just to go highlight them. Okay, pause the video, go do it quickly. Alright, so assume you've done it. Let's see if you got it right. Okay, so if I look at -1, just looking here at this point, okay, and I go to the left over here, okay, is my graph above or below, okay, in this area over here, if I'm looking at these x values here, okay, all of these x values, okay, all of these x values, okay, and forever this way, okay, where's my graph? Above. Okay, can you see it's above the x-axis there? Can you see that? It's above. Alright, so I'm going to highlight that part. Okay, let me highlight that. So that's my above. Okay, now if I look at this side, okay, at this x-intercept, okay, and I look at all of these x values here, okay, and forever that way, okay, and forever that way, okay, for infinity, okay, so this is going to go to negative infinity, this is going to go to positive infinity. Right, where's my graph? Okay, is it above or below? It's above. Can you see that? There's my graph. It's above. It's above the x-axis there. Okay, so I'm going to highlight that. That's where it's above. Right, can you see that? Right, there's my x-axis, above the x-axis. Okay, now if I look here and I go to the right of this x-intercept, I go to the right here. Where's my graph now? Now my graph is underneath the x-axis. Okay, it's underneath. Okay, until I get to that x-intercept, and then immediately after that x-intercept, okay, my graph is now above the x-axis. Can you see that, guys? Alright, so go find your x-intercepts and then just go highlight where it's above and below. Alright, now if they say, where's my graph, where's the y values, above the x-axis, we already know, we know it's the blue part. Okay, that's where it's above. Alright, and is that to the left or to the right of this x-intercept? Okay, this blue part, is it to the left, all these x values, or is it to the right, all of these x values? It's to the left of -1, to the left of -1. Okay, can you see? Now my graph is above. Okay, now my graph is above. Okay, to the left there. It's all above. Okay, so to the left means x is smaller than -1. And I've got another blue part over here. I've got another blue part. Okay, my blue part here, if I go to the right of this x-intercept, I go to the right, my graph is above. Okay, to the right means what? Means x is greater than, what's the x-intercept there? 1. Okay, can you guys see that? I hope it's getting clearer now because I'm going to start moving faster. Alright, and where's my graph below the x-axis? Okay, it's in between these 2 points. So let me draw a ruler here. Okay, so if you put your hand over here, there's -1, and over there, there's +1, and in between these 2 lines, in between, can you see that my graph is underneath my x-axis? Here's my x-axis. Let me highlight it in black for you. There it is. There's my x-axis. Okay, can you guys see that? There it is. Here's my x-axis. Let me highlight it harder. Alright, nice and black. Okay, can you see that my graph is, my green is underneath the black. It's underneath, in between these 2 lines. Okay, so x is in between which 2 values? X is in between 1 and -1. Okay, so x is in between 1 and -1. Okay, x is greater than -1, but x is smaller than 1 because it's in between those 2. Alright, can you see the difference? Okay, I hope that's making sense. Okay, if it's not, just go back, just reverse a bit. Okay, now looking at my hyperbola. Okay, that's a hyperbola. How do I know it's a hyperbola? 1 over x. 1 over x. Okay, alright, and that's how we draw it. And there's my asymptote, okay, at -1. Okay, and that point over there we've got as 1 and 0. Okay, now one thing about the hyperbola that I want you guys to note, okay, is that sometimes they can ask you the axis of symmetry. Okay, same as with the parabola, we've got an axis of symmetry for the parabola, but we also have an axis of symmetry for the hyperbola. Okay, so the hyperbola, we have 2 axes of symmetry. We have 2 axes of symmetry. Okay, so the hyperbola has 2 asymptotes and 2 axes of symmetry. Okay, so if I take a ruler, let me show you. Okay, and I take a line, and I'm going to let me get a line here, line there, there. Okay, and I draw a line straight through this point over here. Okay, can you see that on either side of this line, so this line over here and over there, on either side of this line, can you see that the graph mirrors itself? Mirror. Okay, can you see that? It mirrored itself. Alright, so that's my axis of symmetry, but can you see that it's slanted now? Okay, and this line, is it a straight line? Is it a hyperbola? This line over here, this specific green line over here, what type of graph is that? What function is that? That is a straight line. Very good. Okay, so axis of symmetry. Okay, we're going to find the axis of symmetry, and we know that the axis of symmetry is a straight line. And if I want to find the equation of any straight line, I always start with the general equation. Okay, now they will say, okay, go find the axis of symmetry with a negative gradient. Okay, so if they say negative gradient, okay, negative m value, basically is what they're asking. Okay, my m value, my gradient for this straight line is always going to be -1. Always. Okay, always. Okay, -1. Are you with me? Alright? Okay, and then my c value, okay, what is my c value for any straight line? The c value is always what? My y-intercept. Okay, and what is my y-intercept over there? What's my y-intercept? -1. So my c value is also -1. Okay, so what's the equation of this axis of symmetry? Y is equal to negative x minus 1. Okay, can you guys see that? I hope that's making sense. But now, okay, so that's my first axis of symmetry. Okay, that's number 1. Number 2 is if they ask me for a positive gradient. Let's see what happens. Okay, so take all this away. Okay, so if they say find the axis of symmetry, okay, but with a positive m value, okay, axis of symmetry with a positive m value, alright, that just basically means that this graph is going to do this. Okay, it's going to do this. There we go. It's going to look something maybe like this. There we go. And can you see on either side of this line, the hyperbola mirrors itself. Okay, so that's also an axis of symmetry. Right, but that's also a straight line, so I start with my y equals mx plus c to find the equation. Alright, and if they say positive gradient, alright, then we know that the m is always going to be +1. Always, if they say positive gradient, okay, always +1. Okay, and my c value for any straight line is also the y-intercept, always y-intercept. And what's my y-intercept here? -1. Okay, so my y-intercept is going to be whatever the asymptote is, guys. Whatever the asymptote is. Okay, if you don't know that. Okay, so then my equation of that line is going to be y is equal to 1x minus 1. Okay, but I don't have to put this 1 there. Okay, so it's just x minus 1. Alright. Okay, so that's how you find the axis of symmetry, or the axes of symmetry. So both of them. So you've got the positive and you've got the negative gradient. Okay, when it's positive gradient, if they say find the axis of symmetry with the positive gradient, we know it's always 1 for m. If they say negative gradient, then it's going to be -1. Okay, and that's the same. Okay, for always. Okay, now looking at domain. Okay, domain is all my x values. I'm going to go quite quick now because I think you guys get it now. Right, so domain is all my x values that satisfy the hyperbola. Okay, so if I look at all these x values, let me draw a little ruler again. Okay, go to my rectangle. There we go. So there's my ruler. Okay, so on my ruler, if you look at it, okay, my ruler is touching. Okay, my ruler is touching the graph, touching the graph. Oops, it's not touching the graph anymore because this is my vertical asymptote. Okay, as soon as I go past the vertical asymptote, I'm touching graph again, forever and ever I'm going to touch graph. Okay, so my x domain, okay, the values that satisfy is going to be x is an element of real numbers, so it's all of them, but which value did it not satisfy? This value over here. And what is this value? X is equal to 0. Okay, so my domain is all my x values except for x is equal to 0. So x cannot be 0 because there's no graph at x is equal to 0. Can you see that? Okay. Okay, same with range. Okay, my range, if I turn this on the other way, okay, horizontally, okay, and I'm going to take this ruler and I'm going to go up and down with it. Okay, I'm touching graph, I'm touching graph. Whoops, I'm not touching graph anymore. What is that? That's my horizontal asymptote. Okay, my horizontal asymptote over there. Okay, and I'm going to go down again. And then I'm touching graph, touching graph, touching graph. Okay, so I'm touching graph for all my y values. Y is an element of real numbers. But y is not equal to, which value did it not equal? Where do I not have a graph? At y is equal to negative 1. Okay. At y is equal to negative 1. Okay. Negative 1. Okay, so y is not equal to negative 1. Okay, can you guys see that? Alright. Now, the values of x, when f of x is greater than 0, okay, I'm going to work a little bit faster. Okay, so firstly, whenever I see something like this, I go find my x-intercept first. Okay, go find my x-intercept. Boom, there it is. Okay, there's my x-intercept. Okay, then they ask me, f of x is greater than 0. Is that above the x-axis or below? It's above. So I'm going to highlight all the parts of my graph where I am above. Okay, so let's go highlight. Okay, so I know I'm above the x-axis here until I get to my x-intercept. As soon as I go past my x-intercept there, I'm going to be below the x-axis forever and ever. Okay, this part of the hyperbola, is it above or below? It's below the x-axis. Can you see? Here's the x-axis, below the x-axis. Okay, now they're saying what's the values? Sorry, let me just neaten this up a little bit. Okay, not touching that y-axis over there. Okay, so f of x is greater than 0. Okay, so where am I greater than 0? Let's go to my intercept, my x-intercept. There it is. There's my dot. Okay, so to the left of this dot, can you see that my graph is above the x-axis? It's above. Okay, but as soon as I get to this point over here, at x is equal to 0, okay, is my graph touching that point over there? No. So can you see that this green part is actually in between 2 points? Okay, it's in between 1 and in between 0 for x. Okay, those are my two x values that this top part is in between. Okay, can you see that there's no red part in this little section, this little area? There's no red part there. Okay, all my graph, my whole graph is above here. Okay, can you see that in that small little area? Okay, hoping that's making sense. It's clear to you guys. Okay, so between which 2 points? X is between 1 and 0. So x is greater than 0, smaller than 1. Okay, and that's where my graph is above. So that's the green part. Alright, now if I look at the red part, okay, if I look at the red part now, here's my red part. So I go to my x-intercept. There it is. Okay, and if I go to the right, can you see that my graph is below, 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 below? So that's all the x values greater than 1. X is greater than 1. And there's another part here. There's another red part here. Okay, there's 2 red parts. Okay, and okay, where does this graph start being underneath my x-axis? Okay, from what point? To the left of this point. Okay, so can you see as soon as I go to the left of this point, my graph is underneath. My graph is underneath. My graph is underneath. As soon as I go to the right of this point, my graph is above. Above, above. Okay, so and x is going to be to the left of this point, which is 0. So x is smaller than 0. Okay, and that's where my graph is always going to be below, forever and ever, all the way to infinity, or negative infinity, sorry. And then over here, always, all the way to infinity over there. Okay, I'm hoping that's making sense, guys. Okay, now last graph for today is going to be my exponential. Alright, and how do I know it's an exponential function? Because I've got x as an exponent. Okay, an exponent. Okay, exponential function, x is the exponent. Okay, right, and that's what it looks like. Okay, there's no axis of symmetry there. Right, so it's going to be nice and simple. Let's look at our domain. Domain is all the x values that satisfy my function. Okay, so there's my, we put in my asymptote there, that is y is equal to negative 1. Okay, that's my asymptote. Alright, all the x values that satisfy this graph. Okay, so if I take a ruler again, do this quickly. Alright, so I'm coming from negative infinity here. Okay, am I still touching the graph? Yes, because this graph continues forever and ever and ever. Okay, so I'm still touching graph, I'm coming back. Yeah, I'm at negative 4 now, negative 3, negative 2, negative 1, and I'm going to 0. Now I'm at 1, now I'm at 2. I'm still touching graph. And as I come past this point that's on my that's over there, if I go past that arrow, my graph is still carrying on. It's still going up forever and ever. Okay? So my graph is still touching. It's still touching my line. Okay, my ruler is still touching my graph there. Okay. I hope you guys can see that. I hope it's clear. Okay? So, what is the domain for the exponential? X is a element of real numbers. Okay, so it's all my x values will satisfy this graph. So if I put my ruler on any x value that I choose between negative infinity and infinity, okay, if I put my ruler on any of those x values, eventually, if I draw a long enough ruler, okay, I'm going to touch my graph, my exponential graph, somewhere. Okay, now if I look at the range is all my y values. So let me just tilt this on the side. There we go. Okay, so if I go from, I'm coming from positive infinity, I'm coming all the way from positive infinity, coming down, touching graph, I'm still touching graph, I'm still touching graph, touching graph, touching graph, touching graph, touching graph, touching graph, and no, I'm not touching the graph anymore. Okay, because what is this point over here? This is my asymptote. Now I'm not touching the graph. Can you see that this green ruler is not touching the graph anymore? It's not touching this thing. Okay, it's not touching this pink thing. Alright? It's not touching it anymore. Okay? As soon as I go above that asymptote, oh yes, I'm touching. I'm touching. Okay, can you see that it's intersecting there? I'm touching. Okay, can you see I'm still touching there? Still touching. Okay, as soon as I go past, I go below. Oh no, I'm not touching anything. My graph is not touching this line anymore. Okay, so my range is going to be all the y values that are above, greater than or equal to, above what value? My asymptote, which is negative 1. Okay, I hope that makes sense, guys. Alright, now the values of x for when f of x is greater than 0. Okay, if it's greater than 0, it's the above. Alright, so the first thing I go do is I go and locate my x-intercept. There it is. There's the x-intercept. Okay, and now let's just go highlight. We don't have to do any of this working out yet. Let's just go highlight where is my graph above the x-axis. Over here. So this is where it's above. Okay. Where is my graph below the x-axis? Over there. Okay, can you see that? It's over there. Alright. Now, I look at my intercept. There it is, here in the middle. Alright. And as soon as I go to the right, if I go to the right of this dot, all these x values over here. Okay, all of these x values. Okay, and to infinity. Okay, my graph is above the x-axis, above the x-axis, above the x-axis. Can you see for all of these x values here, my graph is above. But if I go in the opposite direction and I go down this way, go to the left, all of these x values, okay, all the way down to negative infinity, okay, all of those x values, where's my graph? Below the x-axis. Below the x-axis, below the x-axis. Can you see that? Okay, I hope that's making sense. Okay, so if you look at that, so where's f of x greater than 0? Okay, to the right of my x-intercept or to the left of the x-intercept? To the right. Okay, it's when all of these x values, okay, what are all these x values? They are greater than or smaller than 0. They're greater than 0. Okay, and where's my graph below the x-axis? So less than 0. Okay, where it's less than 0, so it's below. It's when x, what are all these x values? Greater than or smaller than 0? They are smaller than 0. When x is smaller than 0. Okay, so it's that way. Okay, right, guys. That concludes this video. I really hope that this was helpful, and I really hope it helps with your tests and exams, guys. Alright, so good luck. my grade 10s, okay?